Okay, so we're going to talk about templates today, and it's in the next chapters. We're going to talk about that, and then um, we have a homework here, building a C++ class. Um, so this is due on Thursday. So you've got still a couple days. One person I see has submitted it, but you got a couple days. But I want to give some time today in class um, to kind of work on it, make sure there's no questions. Um, a lot of stuff is pretty similar to things that we've seen before, but it's a matter of how do we start combining those different pieces. I know I had some people come and ask me questions either after last class or on Friday, and so that's fine. That's what the office hours are there for. But I want to give you a little bit of time here and now since I know that you're available. Um, and you know that I'm available. So if you have any questions, you can go through that. So, like I said, this is going to be, we're not going to take a whole lot of time today because I want to give you some time. If you have had a chance to work on it, you can look at it, ask questions, or maybe get started and go, oh, I need to think about where I'm going with this. So, kind of where that is. The other thing that I wanted to mention is, and I wasn't sure if they were going to do this or not because of this term and the things that are just outside of everyone's control. But there is, we just got an hour ago, literally, um, the final course evaluations. You guys have seen these before. Um, Same website. If you need this website, I will be more than happy to post it for you guys. Um, the, uh, you know, it's just a chance for you guys to give some feedback on the course. Obviously, there's a lot of stuff that's outside of our control, and I understand that. But it does give us some chance to kind of think about what are we doing, how are we going, and different things like that. If you have any suggestions, please let me know. I will also have my own kind of course evaluation, for lack of a better term, that I would like for you to fill out. I will provide a URL to that. Either Thursday or next week. That is independent of this. And it will also be like this, where it's totally anonymous. I won't have any idea of who wrote what, so don't worry about that. But just a feedback for me, so I know how things went, based on things that I'm concerned about. I care about. They're going to be separate from this potentially. So when that comes about, please let me know. Oh, yuck. um, please let me know, and we can update this. The oh yuck is I just saw I updated the plugin that does the color coding um, for this. Anytime there's code inside of the class notes page, and boy, did it screw up the the coloring. You can't hardly see it. I got to go see if I can fix that. Oh, that's a mess. Um, so that literally got updated yesterday, and I didn't have a chance to look at it until just now. And I'm going, oh my goodness. All right. So outside of that, let's talk about what we're going to be doing today. So um, previously, we've looked at uh, overloading a function or overloading a method. And we talked about how we can do slightly different things with the same functioning if it makes the same sense. And we had an example early on when we started looking at function overloading, where one of the things that we did was we looked at finding like a max value. So if we passed in a couple values, we want to find a maximum value for a given um, between two given values. So if I had two integers, I could write a max value function that took in two integers and returned an integer. If I wanted to have a maximum value for a double, I could take in two doubles and return a double. I had to overload that function. And then if I need to do it for chars or strings or anything else, those would all be built up, and I could see that information. Excuse me. And then that would then go about the process of kind of letting me, for lack of a better term, letting me see how effective it was for me. I would have a chance to, the compiler would figure out what data types were being used, and it would pick the right function, but I would have to write all these extra functions, and it'd be a whole bunch. So, and I don't know who came with it first, but a lot of modern languages have been supporting something that they now call templates. This is actually something that it wasn't available to me when I was learning C++. So this is a newer, I would like to say this is a newer thing, but the fact of the matter is I started learning C++ probably 20 years ago, so it may not be super new to C++, but you'll see it in a lot of languages. You'll see it in Java, you'll see it in C#, you'll see it in other languages too. And what it is it allows you to define what we call a template. And the template says that whenever there's a data type, and I've got a template here, you can plug in that template. You can, and now whenever the function gets called, the compiler says, oh, wait a second, you're passing me doubles. So I'm going to put doubles in where that template parameter type is. Or, oh, you passed me a character this time, so I'm going to put a char where that is. Or, oh, now you're passing me, an integer, so let me put an integer. Oh, it's an integer again. We'll put, and it will update it constantly depending upon what data type it sees that you are going to need. So it's a really cool thing. And the basics of this is you're going to have a template name. You're going to say template. You're going to say type name, and then you give it a variable t. Now, the one downside to this right now, this is just a very simple example, is that t has to be the same data type throughout the function. If I want to use other other dynamic types, for lack of a better term, then I have to create some other type names in here. But for right now, we're just going to look at one. We want to keep it simple. We just have the one. And you notice where I have my function name beforehand, I have a return type. A return type is t. That's because it's going to be changed by my type name later on. And then in my parameters, I have t value 1 and t value 2. Once again, that t is just going to get replaced with whatever the template name comes in. And anytime I need to define what t is, I can do this. So I have return type of t, I have all those different things. If I need to create a temporary value inside of this function, let's say I was doing a swap, I could put a t in there. Okay, so we have a lot of functionality in this simple process. So let me show you what it'd be like to write something like this. Okay. So I have down here my max value as an example. And I could, under what we previously did, I would say something like int max value, int v1, int v2. And then I would specify something like if v1 is greater than v2, return v1, else return v2. Okay, and that should look pretty familiar to what we're used to, right? So what we're going to do instead is we're going to say template. Okay, so we have to always define that we're going to use a template as such. Then we're going to say inside of our angle brackets, type name. And you'll notice that this comes up with our kind of look ahead that Visual Studio gives us. So now not all programming languages or IDEs are going to give this to us, but if you are using Visual Studio or Visual Code, you should get the little look ahead type. So you can just kind of scroll to it or click on it, hit enter, and it'll fill it in for you. And then we're going to specify T. Now at this point, you'll notice that max value, if this wasn't here real quick, max value has lots of issues because it's saying, oh, wait a second, you're taking a character, you're taking a string, you're taking all these different things. It has an issue. I can't handle that. So that's what we're going to do the template. Anytime I have int, I'm just going to replace this with t. So what type am I returning? I'm returning type t, whatever that is. What about v1? Well, that's going to be a template type. And then int for my v2, that's also going to be my template type. Now, if you look at this, I have no more errors down in my code down here where I have my main. If I go and I run this, boom, everything is out there working. Now, there is a couple of interesting problems. Take a look real quick at what is displayed in the answers, and let's see if you can find what a potential problem might be in here. And then once you find that problem, think about why it might be causing us a problem, if there's a way to fix it or not. But if you find it, go ahead and just raise your hand. You don't have to like chime in or anything. Just raise your hand. See if you can see it. Just look kind of line by line between A and D. D is bigger, etc. Just kind of go through and see. When you find it, just kind of use your little hand raising icon. No one's found it yet? When you find it, when you see it, you go, oh, duh. All right. Who's given up? If you've given up, just kind of raise your hand and let me know, and I'll point out, or I'll give you guys another minute to figure it out. One person's like, yep. All right. So here's the issue. We'll just go by these line by line and see if these make sense. Okay. So the first one I use, and I'll pull this off to the side just so you can kind of see it where it is. The first time I call max value, I say between the character A and the character D, D is bigger, and that makes sense, right? If I go alphabetically, A, B, C, D, D comes later in, so it's bigger. Does that make sense? Then if I say between the string A and string D, A is bigger. Now, why would that change? That doesn't make sense. Then I have between lowercase a and capital D as characters, A is bigger. That makes a little bit of sense. Between 7 and 3, 7 is bigger. That makes sense between 3.14 and 2.17. 3.14 is bigger. So pi is bigger than E. Okay, so the two that throw us should be that, first off, lowercase a is bigger than D. And that goes back to, if you remember, that a character is actually stored as a number, and it correlates with something in our ANSI table. So you might say, well, how does A still wind up being bigger than D? Well, it's lowercase a is bigger than capital D. So it's not a is bigger than D, it's lowercase a comes after, in my ANSI table, after my uppercase letters. So lowercase a would be bigger than uppercase Z, just because of it's given a numeric value and where that value falls inside of our ANSI table. Okay, so that's one thing that should have been a little like, I wonder why, is this actually correct? And I would have to go and maybe look that up when I'm verifying this. But when I look at my two strings, A and D, that should not be. A should not be bigger because A and D are both capitalized. They're both strings. Everything should be going forward. So what's actually happening is that, remember, these are C-style strings because we just put them inside of our quotes. Remember, we talked about that, and that sometimes has some issues because it often has to deal with, it's actually an array of characters, a special type of array of characters. So that's why we had so many special types of comparison functions. We didn't want to just use greater than or less than symbols. We wanted to use a string compare. So part of that is because of, it's not that it's a string, it is an array because it's a C style string. And so it's probably looking at the memory address. So I'm going to change this real quick to say string, and I'm going to create a string from that C style string. So now I have a string object. And if I run this again, now when I look at my two strings, A and D, D is bigger. And that's should be what I'm expecting. That's what I should expect to see. Okay. So the way that got fixed was because we changed it from a C style string where it's using that less than or greater than symbols in order to calculate it. And it might be looking at memory locations or something weird like that. And now we're looking at a string object. And the string object is now talking about, hey, I can compare these. I know how to compare these. Okay, so that's one of the big advantages also to using a string object compared to a C-style string. And that's a very simple and obvious place where we might forget about it and go, oh, why is this giving me bad data? I'm not expecting bad data here. And that's one of those little logic errors that we can run into if we're not careful. So just as a kind of FYI, you want to keep track of things like this to make sure that it's not going to give out and we're not going to have some issues. Okay. All right, so let's look at a couple other things just real quick and see what's going to happen. I'm going to take this A and D here. By the way, if you didn't know, Control D is a line duplicate. So if you're wondering how did I type that so fast, I didn't. I cheated. Okay. I'm going to say I want to pass in a string and compare the string against my character data type. But if you notice, when I do this, there will be errors. That's because at this point, and we're keeping things simple right now, all of my templates data types are the same. Okay, so I cannot go switching things. It does not understand that. This is where I need to either, once again, use function overloading or handle multiple data types with my template. Okay, so I'm not going to run that again. You can also see that it puts little squiggly mark underline. So if you ever get a situation like this, you go, well, wait a second, I've got my template. Think about, okay, am I using the same data type throughout the process? Okay, that is a big thing. All right, I'm going to include real quick. Oops. Hold on. I know it's not finding it. It's just the angle brackets, not my quotes. Okay. So I'm going to come in here and I'm going to change this to be circle 4 versus circle 3. Okay. And we'll come over here and change our C out. Okay. If you'll notice, I still have a bit of an error here. Okay, not what I'm expecting. If I go and try to build this, you're going to see that we get an error. And part of this is that it doesn't know how to handle to determine how do we know that a circle is bigger? How do we return and print out a circle data type? Any of those types of things it gets all confused about. It doesn't know how to handle. That's why we're getting these errors. So until we're able to provide a better methodology for knowing how we're going to print out a circle, how do I determine if one circle is bigger than the other, those types of things, this just is not going to work. So that's just something kind of keep in the back of your mind. We're going to talk about that later on. Don't worry about it, but this will be a potential issue. I'm just going to comment out that line real quick so you can skip past it. Okay. Now, if you build, you'll see that everything comes up and it gets fixed. We're all good. Right. So that's the real basics of a template object. Are there any, or excuse me, not a template object, excuse me, a template function. Is there any questions about using template data types in a function that you guys would like to bring up at this point? Any questions on what you saw, ways to fix, ways you can use this, etc.? Okay. So, like I said, this basic idea is available in a lot of other languages. This becomes very, very helpful, especially when we start talking about templates in classes. And that's going to be the next topic we're going to reference. In fact, I am using this very thing in the next class in C#. And we're going to be looking at, probably not today, but on Thursday, building a template for a built-in class. That way we can assign it the data that we care about. And that's the important thing, is it's data we care about. So if I look at this, this is how I would define like my header. And there's an example that's in the book that we didn't look at because we'll actually go into a lot more detail about it in a class this upcoming fall called Introduction to Data Structures. So if you are planning on continuing on in the fall with computer science, you'll probably take that course, CISC 210, Intro to Data Structures. And we talk about stacks, we talk about queues, we talk about a lot of other data structures that you need to know about. And since we spend so much more time in detail, I didn't really want to cover some of it today or earlier this term. But the basic idea of a stack, and a stack has some uses in programming, is that it's a special data structure which is going to hold information for us to retrieve at a later time. You might say, well, how is that different than any variable? Well, a stack is going to be a collection of values that you can use. And it works on the basic principle of last in, first out. Okay, so something's called LIFO, and last in, first out is the last thing that gets added to the stack is the first one to get removed from the stack. And so it creates an interesting little tool for us to do. The problem is if we were to implement this in, let's say, C++, is that we'd have to create a stack for an integer, and then have to create stacks for strings, and have to create stacks for whatever it is. So it'd be a whole lot easier if I could just create one generic stack class and then define the data type that gets applied to it. And so that's what this is doing. And here's what we would see as the header. We see a template, type name T, and that should look really familiar to us. The class stack, that's fine. And then we have some public methods. Constructor is empty, peek, push, pop, get size. Those are all standard things. Okay, and when we talk about them in class coming up, we'll look at those in a lot more detail and how we can affect those. Okay, then we have our private elements, and we have data type T elements, and elements is just an array of type T, whatever our T is going to be. And then we have an integer as a size. And a key thing I really want to point out about with this is notice that with like is empty, there's a bool return type. Peek has a T return type. Our elements are a T type, because it's part of the template, but our size is always an int. So we can mix and say, hey, not everything has to follow this template. There are some things which are specific. That's fine. You can do that. This is a perfect example of that. Okay, you don't have to templatize all your data types. There can be some that you keep a specific type for a specific reason. Okay, so when we start to build this out, so the previous section would be like in our .h file. This would be like in our .cpp file. So once again, I have to have template type name T in front of every method. And because the class itself is a template, when we define our stack, anytime we define our class, we use stack angle bracket T. Okay, this is letting us know that we're using a templated type of predefiner for handling and defining, classifying where our method goes with. So we have stack T, which is before our stack. Notice our constructor doesn't have that angle bracket T after it, okay? Just before. We got template type name T in front of our Boolean stack to see if it's empty, okay? And on these things go. I've not filled in how those are going to work. We're not concerned about that. You can look in the chapter if you're really concerned about it. You want to kind of get a heads up on what's coming up for next term. Feel free to. But this is just designed to give you an idea of what would a class look like if you were defining it, if you're building it out. So in some cases, like with your peek method, notice that it returns a type T, and then we say stack T to be how we're defining what this method goes with. Whereas with is empty, we have a very specific data type that we're looking at. When we go to build our class, and this is kind of a key thing, I say stack, that's our class name, and then I'm going to create our object from it. It's going to be in stack. But between when I do that, I need to define what data type we have. So remember, an array, if we go back to think about arrays from a couple weeks ago, arrays have to be all the exact same data type. I can't mix data types inside my array, not in C++. Other languages I can. C++ is more specific, more detail about how it's going to handle that. Okay, so you're looking at, I need to specify, hey, this is an integer, and this is going to let C++ know, hey, anytime you see a type T, it has int inside those angle brackets, replace that with an int. And it goes in and handles it. And I can create multiple stacks just like this. Some could be ints, a couple could be doubles. I can have a character stack. String stack does not matter. It's going to look at this and it's going to say, oh, okay, I know what this is. Let me apply this and make it work. Okay, so that's just an important thing to keep in mind. I can create multiple objects using different data types for my stack or whatever my class is going to be. Um, but I just need to define it as such because I cannot have multiple data types within the same class. It just C++ gives you a lot of flexibility with this, but doesn't go quite that far. Okay. Any questions with class templates in what we looked at? Okay, sweet. All right. So, like I said, I knew we were going to get done early today. Um, any questions with before we finish up today and let you go start working on the project? Any questions with this particular example and how it was figuring out the different data types or why we had to put string in here instead of using the C style strings? Any questions with that part at all? Okay, that's great. This is a little bit, you kind of got to get your mind wrapped around it. It's also part of the reason why I'm not doing a huge long thing, is I know um, this is a little bit different, and I've tried to find the best ways to explain things, but I know it can be different and take a little while to get your mind wrapped around. So I want to make it as easy and convenient for you as possible. Um, if you haven't had a chance to take a look at the um, homework for this particular coming up, um, it is obviously posted on Moodle. It's taken the circle class that we've been working on inside of um, class examples and stuff like that so far. We have our radius. We've added two new properties, our x coordinate and y coordinate. You don't have to call them that. You could call them x and y if you want to. X coord, y coord, whatever you prefer. It's just two simple doubles additional to your radius. Okay, and then we talk about the different things you're going to need. Make sure you follow kind of everything and nothing gets missed. If you want me to look over any of your work and make sure that it's meeting all requirements, of course you are able to. I would also recommend that you make sure that you have good um, planning and thought process in this, comments to kind of lay things out. This is going to be something that we're going to be looking at going forward. Um, so make sure this is something, if you were to come and pick this up in 5 or 6 weeks, you go, oh, I remember what I was doing here, and we're able to quickly follow up. Um, the key things that we have going forward from this versus what we've done in class is adding collision detection, determining distance, and add those XY coordinates. Really is not that complicated. Hopefully it should take you about an hour or so to do total, if you take some hints and whatnot from what I've built out. So I'm going to stay online. If you are done and you don't have any questions on the assignment, you're of course free to go. Thank you for coming today, and I'll see you on Thursday. If you haven't had a chance to start, you want to kind of start, I will be sticking online until 12:15 when the class normally ends. That should give you about 40 minutes or so to work on it, ask questions and different things like that. And then if you have already gotten started and you have some questions, you can also ask them now. Or, like I said, I've got the office hours. If you look at the general section in our class Moodle, uh, and I'm using, because I'm here and still in town where Tusculum is, and figuring Tusculum is a good point of reference. Morning is anything before noon, afternoon is anything afternoon for school time, so Eastern time zone. Um, so if you don't see me in one, you might be off a little bit because of lunch or something like that. I do take lunch at noon. Um, but do feel free to come by. Those are on Tuesday and Thursday. If for some reason you can't meet during that time, I have met with some students on Wednesdays as needed. So that's there as well. All right, I'm going to stop sharing real quick. So I'll mute my line so that I don't disturb anyone. But if you have questions, just chime in, and I'll unmute and be more than happy to answer stuff. Otherwise, have a good day.